Okay, you should be the host now.
Right. How does that look?
That's good.
Get rid of the waiting room. Okay. All right, can everyone see my screen? Cool. I'm almost caught up on grading, so people should be able to see most of their scores. All right, we've got 9 people here. I don't have to be in a rush today because we don't have just 40 minutes. Someone asked me in the AM lab, which is this one, I got to the 40-minute mark and I didn't have the plot for Monday's lab working by the end of the 40-minute mark. I restarted everything, but that wasn't recorded. The fix, the solution is in the paste bin for that lab. So, okay. Today's lab is going to be a lot like Monday's lab. I already ran through this copying and pasting because that's pretty much what it is. It's using the knowledge and basically the code cells from the lesson to work on another example, because at this point you shouldn't be surprised. That's what the homework's going to be. Same thing, just doing some more. So the homework is going to be using all of, I think it's all of them, all of the models that we've gone through. So linear, exponential, logarithmic, and power law. The lab is just going to be doing logarithmic, I believe. Look, or whichever we want. So we can pick any of those. Linear is fine, whatever's fine. So the name of the game, I used logarithmic when I went through this morning. The name of the game is pick the appropriate things to copy, put it in here, and make sure it works on our data. And since it wouldn't do everyone a whole lot of good for me to just copy and paste, what we'll do is do it together. So we can pick which parts we want to copy, and then we can plug in the data ourselves. Luckily for us, we've got a nice scaffolding for what we need to do. So let's start. Okay, we need the necessary packages. Well, that's not very difficult. Hey, look at that. Catherine beat me to it. Not very hard. Just basically look through here and find the one. Now, sometimes the packages will be loaded in more than once. Totally fine. I don't know of any that it causes a problem if you load it twice. Maybe if you give it a different moniker, I don't know, but it doesn't hurt. at least in my experience. Okay, so if we need more packages as we go along, we'll go get them. Next thing, build the data lists. All right. We could just do just like this. And make sure that the data we have been given is what goes in here. Now, I don't think it's probably just easier to do it manually, because I was going to try to copy and paste, but these are like in a vertical format, which makes things kind of not easy, but no big deal. I've found myself when I'm doing, I have to do a manual, listing stuff. It's nice to say them verbally so I don't lose where I am. This one's just, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We don't need the 12. This one we'll have to do. So 9.8, 5.9, 3.9, 2.1, 1.0, 0.8, 0.6, 0.4, 0.3, 0.2, 0.1. Okay. So 1 second. All right. I was just making sure the video uploaded. So we got the data lists. Cool. Actually, what I'm going to do is I'm going to make different cells for stuff. That way we can run them individually. Okay, data lists are in. Got time and voltage. Next thing to do is build a data frame. Done this a million times. So how should we build a data frame? Also, we've arrived at the point where we need to decide which model we want to use. So I'll let the audience decide. Linear? Okay, works for me. Let's see, where's the, I think, was there a linear example today? Okay, shouldn't be tough. We just don't do the log apply. So if we run into problems, we'll just change it. All right, you guys are on the ball today. So I got 2 of them. I think both will be fine. I like Todd's because, wait a minute. Oh, it's the homework. Because I like that the, what are they called? Column names are more descriptive, but either one would be totally fine. All right. What do we want to call our data frame? Could be anything really. I'm going to hesitate to call it data just because I don't like when we run into like giving a parameter and data equals data. I mean, so it's an easy, simple fix. All I'll do is say my data. Now that's just totally personal preference. It would have been totally fine. Now, what's a method we can use after we build a data frame to just take a peek and make sure it exists? Yeah, head. So df or df my data dot head. Okay. All right. Hey, look at that. We got stuff. And it appears to be correct with our little listing here. All right. So we have our data frame. All right, next thing, initialize and fit our regression model using stats models. Now, I'm sure some of you guys have already beat me to it because you've been pretty quick, but be real easy to just control F stats models. But I think I already saw it. Yeah, it's right here. So let's try just a quick copy and paste and make sure we change what we need to change. Now this needs to go my data. And I forget exactly what this string is for. I'm thinking just a label. So I'm gonna just try to change it to what our titles are. And if it doesn't like it, oh well. Okay. Next part, predict the values. As you can all see, this is a pretty simple task. You just have to make sure all the wires are put in correctly, which that is not always easy. I mean, I messed it up a couple times, but that's going to be something you run into a lot when, and I mean a lot when you're in industry doing stuff and you need to do a particular, I don't know, algorithm or something. So you look it up on the internet, find one that works, and you start working with it, and it just doesn't work right. It's tough to. Oh yeah, I think you're right. It's just weird putting the time second. Okay. Predict the values. That's here. I believe all of this. Do we need to change anything? I don't think so. Let's see if it even runs. Didn't have a problem. All right, plot against the data. Super simple. Now, let me take a small amount of time to emphasize, it's a good word, how important good documentation is. Ooh, I got an echo. Just the fact that somebody put some comments here makes everything so much nicer. And you might think to yourself, well, that's not that big of a deal because you only need it when you're working with multiple people, right? Like Dr. Cleveland wrote this and I didn't write it, but he wrote comments so I can go look and see what he was trying to do. But I will say it is also super useful just for yourself because you aren't the same person that you were before you go have lunch or whatever. So comments are nice. Documentation is nice. Let's put it that way. Okay. Need to change this. Let's see. Anything else? Key error. Right. And I believe that's needs to be what these are. So X is time, right? This will be voltage. This will be time. Let's see. Time is X. I think so. All right. Data is not defined. Blah, 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 blah. Where? Oh, there it is. Okay, we got something. It's not just visually. If I had to draw lines, not terrible. Because let's see here. So let's pretend we are only getting, I guess I can go left or right. We've only got 2 points. Well, that's easy. The line goes like this. Well, now we have 3 points. If I go here, I miss the second one. If I go here, I miss the third one. So it's going to kind of go there. All right. Now I've got another one and another one. And now we're getting pushed down. So we kind of need to start like right here. And eventually we're getting pushed more and more this way. So I can see how that's an appropriate approximation. Okay. Well, I kind of just spoiled the next part. But we do have to ask ourselves if, so the tools in our arsenal are do a linear approximation, exponential, power law, logarithmic, or polynomial. Do we think that the linear approximation is good? So I'll ask the audience, and don't just say yes so that we can end early. Although, I mean, I guess you can. Okay. I agree. Let's try at least one more. So which one do you guys want to try? Logarithmic? Okay, good choice. That's simple to do. All we have to do is transform our data into the log space. Here. I'm just thinking because the variable names are different. What I'm thinking is, so I'm going to make a new, I guess I don't have to. So I have T and V as my list of stuff, and I use T and V in my data frame. Now I could just replace this with Y, and that's what I guess that's what I'll do. I was trying to think, could I maybe say V equals Y? But I don't remember if this will be a shallow or deep copy. So we're going to do it this way. All right, we're going to transform our output data into log space. See what it looks like. Kind of strange, but okay. Let's see our new data frame. Now, does it make sense when I say put this into log space? Do you understand what I mean when I say that? It's not something, yeah, essentially, convert the values into a log value. Yeah, so I'll try to explain it. So when we plot something, this is our linear 3D space, okay? And why do I call it the linear 3D space? It's because everything that goes into this, consider every point in this 3D thing I'm building, the space. It's the place I put stuff. If I've got the data for, I don't know, some line that goes through it, it's the linear space because I don't do anything to that data. I can also have a 3D log space, and I use 3D just because it's easier, but it works in 2D too. So I've got my linear 2D space. I've got an equation for a line. Cool. Now, I also have something called an exponential space, and It's just putting all my data, transforming it with just the e to the whatever the data is. Because I'm doing the same operation to every piece of data, I haven't messed with it. It's just warping a little bit. It's like putting a new lens on your microscope or whatever. Or putting, here's a better example. Now I wear glasses. If I put a red filter on my glasses, I haven't changed the world. I'm just viewing it differently. Okay, we've made everything into log. We need to do anything different. I don't think so. I think the OLS package knows what to do, but not sure. Let's just look, see what happens. All right, I changed that. Do that, and do that. All right. So do we think this is better than V? Do we think picture 1 is better? Or picture 2? I did change the data frame values. So here's the data frame with picture 2, see 2.2, 1.7, blah, blah, blah. When I change it back to what it was originally, it's 9.8, 5.9, blah, blah, blah. But yeah, it's a good thing to check. So this is picture 2. Remember, this is in log space. So that's the reason it's straight. Do we think this one's better than the old one? I think so too. Now, there is one more thing we should do. Is we have the log space filter on right now. We should transform it back and see what it looks like in linear space. So how do we do that? It's not hard. So let's say I want to put this isn't technically true, but it's a good example because it's easy to think about. I'm going to put something into x squared space. Okay, I apply square to everything. And to get it back, I use the square root to get it back out. Now, the reason that doesn't work is because square root's not really a function, but you get my point. The inverse for log, it's right here, is exponentiation. Now, this will be voltage, right? And this will be time. Now, in a good IDE is the environment we do all of our coding in. You'll be able to do a find and replace. So the this isn't the exponential model. I'm putting the reason we're using the exponentiation function is because it is the inverse of log. So I'm taking all of my log transformed data here. Where is it? Here. We transformed it all into log. And now what we're going to do is we're going to apply the exponentiation function to get it back to linear. So all we're doing, we did the model predict here. We're not running this again. We're just plotting it in linear space. So this plot right here has the log filter on. This plot right here doesn't. And you can see they're going to be very similar. Well, I mean, the scale changes. All right. My data. This was time. This should be time. Did I miss anything? Don't know. We'll find out shortly. Okay. So yeah, this looks better. Do we think this is good? Let's poll the audience. Yeah, I think so too. All right, so we have a model that we're okay with. Very cool. Now we need to answer the questions. Okay. So what voltage do we expect after 1.5 seconds? How would I answer that? From the graph? Yeah, I could do that. But it would be nicer if we could just actually plug it in. So I think there's an example of that. Maybe not. But let's see. When we did the model prediction, we should have a function that we can plug into. And if I can't find it quickly, I'll go look in the documentation. Oh, there it is. Duh. So what do we got? (2.12) minus, I'm just doing this in my head. So 1.5 divided by 2. Be pretty close to what we were looking at here. But since we have a computer, we may as well use it. 2.12 plus 0.436 times, and what were we looking for? 1.5. So yeah, that's pretty close to what we were eyeballing, which would be here. Yeah, so Catherine, I used the titles or for my columns as time and voltage because I like them that way. I believe the example is using X and Y. Either one's fine. You just got to make sure that you use them consistently. I can't say time and voltage here and then say X and Y here. I have to replace them. So depending on what you did here, you either need to change this to X and Y, or if you don't want to do that, you need to change all the X's and Y's to time and voltage. Okay. If they are all the same, I would need to see it. Because it's really easy to miss one. It's really, really easy to miss something that was replaced. So I know your struggle. All right, so that's 1.5. And we can do 15 as well. I think negative voltage makes sense, does it? I don't know. I think so. Yes, I see. I wonder what happens if we do this. 8.381. Math dot. Yeah, that's what I'm trying now. Just because I'm curious. EXP, isn't it? Okay. I forgot to do this. Negative 0.436. All right, that makes more sense. Now I wonder. Yeah, that makes more sense. Yep. Okay, so that's pretty simple. Plugging in the blah to get your output. How do we do the other way around? How do we want to? I want a particular number to come out. How do I do that? Catherine, did you figure it out? Okay. Rearrange the equation in terms of X. I could do that. I was just thinking we would do, so what is it, 1.5? So start here. And I'm going to keep going up until I pass it. That's pretty close. 3.7. 8. That's good enough for me. Now, what Parth is saying is, this is an equation, right? Y equals this. So if I rearrange, so this is my X. If I do algebra to get my X on its by itself, I can just start plugging in 1.5 and 0.7. So I would divide both sides by 8.32 and then apply the natural log to this, and then I would divide by negative that, and then I would have the equation I want. But because I knew that this is a pretty simple thing to get to 1.5, I could just tinker with the X. And the same thing works for the 0.17. I don't remember exactly what this was. Oops. 0.12. And I want to go back a little bit, don't I? 0.18. 5. I want to go this way, right? Let's 1. That's good enough for me. Okay, so that's how you do that. 8.85. What would I want to do with that? Oh, this is 017. Yeah, you're right. Yeah, I was not doing it correctly. Yeah, you got it. I was adding a 0 here for some strange reason. Okay, so that's that. Catherine, if you still haven't figured it out, I believe it's okay for you to share your screen. If not, someone tell me quickly. So if you share, I'll try to troubleshoot with you.
I'm going to talk on this. Can you hear me?
Yep.
Okay. So I ran it again and I changed it to the log like we talked about. And that all worked fine. And then whenever we get to the actual plotting, it's whenever it says the time is not defined.
Could you scroll down to the bottom of the red text? Okay. All right, scroll up. Keep going up. Where did you make your data frame? Okay, I see the issue. How do I say this? I think I'll just tell you rather than try to get you to it, because this is one of those errors like missing a semicolon that it's almost immediate story time. Programming competitions, not all of them, but some of them are designed for 2 people to be on a team. Now, why on earth would you have 2 people working on one computer? It's simple. So that while you're tacking along, typing your code, and you miss a semicolon, well, the other person is not inside of your head. So they don't have the same catch-ups. So they see that a lot quicker. You made your data frame just like I did. It's called my data. You are trying to access a data frame called data, and it doesn't exist. So if you scroll down to where the error is, right, like the second line on that cell there, see where it says plt.plot?
Oh,
You're trying to use a data frame that doesn't exist.
Oh, okay.
Yep.
That makes sense. It was just, okay.
Yeah, all your data need to be replaced with my data. It's not that it doesn't exist, it actually does, but only inside of the model. And yeah, that's why I won't say the error message isn't very good. It's just, like I've said a million times, computers are stupid. They're just very fast. All right, let's see what the next error is. Okay. So if I recall, when I had to, here. I don't know if you have that line. It's 2 lines really. But yeah, those were needed. Here, I'll kick you off and show you mine. So before I access this part of the data frame, I had to actually make this column. So when you try to access a data frame, the error you got was that this doesn't, there's a key error. It's because you didn't make it yet. Okay, I believe Hunter wanted to ask something, and yeah, we've got like 5 minutes. You can ask whatever.
Yeah, I guess I'll share my screen.
That would be wise.
So I'm trying to get it to where these are all going to show up as different colors, or I guess it's just a more general error that I'm getting to. So my data frame his name's CS, and it's been working so far until I got to here. I changed the names of the columns to make them simpler, and that worked fine. But whenever I get here, for some reason, it's giving me that error as if that column name or that column doesn't exist in that data frame.
Can you scroll up a little bit? Okay.
It's named CSMPA.
I'm thinking. That line up, that one there, the really long one.
Yes.
What's going on here?
That's where I changed the
Okay. Can you do cs.head after that?
yes. Huh.
There's your problem.
Okay.
Yeah. So general tip, when you do, especially since you did like a million things all in one line, which is fine.
Right.
When you do an operation like that, it's probably a good idea to look at whatever you just transformed just to make sure it looks like what you expect it to.
Okay.
And I'm betting it doesn't look like what you expect it to.
Right. So why would it show that the name's changed here?
I swear we've had this exact same conversation before.
So I had to go back and find it. It was this lab that you helped me with before.
Yeah. So let's do the same thing.
well, I
Go
had to
back
print-
to what we're working on
All right.
and go to that big bajillion line.
Yes.
All right. And every time you see a comma, I want you to hit the enter key. Okay, now that's easier to read. Okay, I think I know what this is. Do you remember, where did I do this? Yeah, when I dropped the columns on Monday, was it Monday or Friday? I tried to drop the first column from the data frame. That I don't have a good word for it. Save this as a variable is what I'm trying to say.
Okay.
This is one of those things where it did it and it printed it out for you, but it didn't save anywhere. It doesn't apply to CS. It just, so yeah, try that and then do x.head.
Run that first. Okay.
Catherine did, oh, she's not here. All right, then.
Oh, thank you for the help.
Yeah, no problem. Okay, is there anything else? How long after the due date can you submit labs? If it's after a week, you're not going to get anything for it. I mean, you can submit it whenever you want, but if it's, I usually look at it, if it's after 7 days, it's a 0. Like if I see, so the due date is like 11:59. If you turn it in at 12 a.m., it's no big deal. Now this is completely at my discretion. There's no rule to it as for what that window is. Could be 30 minutes, could be an hour, I don't know. Next day is like 1 point off, and then After 7, it's 0. Okie dokie then. Well, everyone have a nice day, and I will see you on Friday.